Hey, how you doing? This is going to be as short a video as I can make it on looming, on what looming really is, and where the globe side have gone completely wrong with their belief of what it is. We're told of the refractive effects of the five effects of refraction, which is looming, sinking, towering, stooping, and mirage. We're told looming is by far the most common of these effects. This is what we're told, but yet can never really be shown to us. It can never be proven that things are floating up from behind an horizon. Okay, the things that are floating up from beyond an horizon, the things that are behind an horizon have been floated up from beyond that, right? But I'm going to show something here. This is from Andrew Thomas Young, okay, San Diego State University, who you all know about. This is what he says at a 4 kilometer target, right, inside the horizon. Now, before I get started on this, Andrew Thomas Young states, okay, that he does all these refractive measurements over a flat plane, and then he adds geographical considerations, something like that. But basically, he uses maths to curve them around a globe, right? So just so you know, okay, this is supposed to be here. What we're seeing here, this pyramid here, this is inside the horizon, right, from 4 kilometers away from an observer. This here is 5 kilometers at the horizon, right? This one here, and this one here is 9.5 kilometers, and it's half hidden by the horizon because it supposedly went over the curve. Now, we're told that looming, right, I'm just going to make it big here, looming, the appearance above the horizon of a distant object that would normally be hidden below it. This effect is caused by unusually large terrestrial refraction. Okay, we'll get back to that in a second. Okay, their claim is that light is bending or being bent down by the denser atmosphere close to the ground, and it's being bent down around a curve, right? Now, if something has been, for a start, the biggest, to completely debunk that for a start, their claim of looming for a start, if it's been bent down around a curve, right, by this denser air, if you watch the pointer, it's been bent down here, supposedly by the denser air, then how does it come back up here in your horizontal view? How can it come back up here into your horizontal view? How can something loom back up into your horizontal view if light has already been bent down? So what allows this light to come back up into your horizontal? Because they're making it out as if we're seeing things, they'll make it out as if we see looming up here. We don't. We see things on the horizontal, always. We don't see things floated up in the air, up in the sky. We see things on the horizontal. So how can things be floated up? How can light be allowed? How can that light be allowed up, but all the rest of the light is bent down? How can that light be allowed out of the dense atmosphere that's supposedly been allowed away from the denser atmosphere at ground level to be up in our horizontal? Right, even if we're standing in dense atmosphere here, according to the globe, according to obviously the globe, we're on a globe, right? This is what they say. So the light is being bent down around it, but yet we see things that we're told are loomed up from beyond the horizon. How can they be loomed up here if we're in dense atmosphere here and all the light is being bent around it? What allows this light that's supposedly looming? What allows this here, this pyramid here, to loom up above the horizon? What allows that to happen if light has been bent down? Because it would have to be up into a much less dense area of atmosphere. You know, it's nonsense. That alone debunks it, because it's a contradiction. The light that's bent down around a supposed curve is allowed back up for us to see in the horizontal. This is the explanation as to why we see so far all the time. This is their explanation. So that alone completely debunks it. But I'm going to bring it further than that. So I'll read this again. Looming, the appearance above the horizon of a distant object that would normally be hidden below it. This effect is caused by unusually large terrestrial refraction. Okay, terrestrial refraction. Okay, terrestrial refraction. This is all from Andrew Thomas Young. The displacement of terrestrial objects from their geometric directions by atmospheric refraction. You may not notice it. You may not notice it. That's the part. That's the tricky part. But it is a major headache for geodesicists and surveyors. Right? It isn't a headache because they sort their headache out with mathematics. Like if you have a headache, you take aspirin. If they have a headache, they take mathematics, because all they do is they take what they see, which is across a flat plane, and they add in a load of globe mathematics. They just match what they see with refractive nonsense. Just a load of nonsense, pre-assumption of a curve. That's all the surveyors do. They take something that's obviously in direct horizontal, and they'll mathematically make a globe out of it by mathematically converting Cartesian coordinates to geographical coordinates. It's just pure. It's pure pre-assumption and belief based. So they'll keep on making a globe out of things, regardless of the fact that they're always seeing a flat plane. They always map everything out in Cartesian coordinates, and they always convert it to geographical, which is latitude and longitude. So if people want to get some very small proof for that, look at Google Earth and go anywhere and put your arrow over any location. Use the satellite function on it, and put your arrow over any location. What will happen is you'll get a latitude and longitude coordinate for it, but you'll also get an elevation. How can you have an elevation with latitude and longitude? You can't. It's a 2D system. So they're switching constantly between their 3D Cartesian coordinates and trying to give you your coordinates in geographical. So they're giving you your coordinates in geographical, and they're switching mathematically back to get some kind of an elevation. Because elevation comes from 3D surveying. Which is Cartesian. Because Cartesian can be 2D or 3D. So there's no headache for surveyors. They just keep on switching. And Google Earth is a good example of the switch that's constantly happening. So we'll move on with Looming. Okay, Looming, here is how they simulate it. They show this curve and all the nonsense that goes with it. You can go through that yourselves. I took this photograph of this. This was attached to this part of here. This is all Andrew Thomas Young still. And here is the photograph. Now, this is supposed to be Looming. But basically what the point of this photograph is we're being told that we shouldn't be seeing these things, that they're being loomed up, or at least some of them are loomed up. I don't know if this is the normal one and this is supposed to be the Looming. I don't know what this is supposed to be. It is like basically the fact is we do see these things, and sometimes we see more than others. But that's down to towering and sinking. It's down to towering and stooping and sinking and mirage. Because the looming as this is not in line with his description of looming. This is from Andrew Thomas Young. Looming, the appearance above the horizon of a distant object that would normally be hidden below it. Now, where do we see this hidden below it? We don't. Now, whether it is or not, I don't know. It depends on observer height and weather at the time. But the point is, we're seeing this object at a distance at this observer height. So I don't know if we're seeing this object. If they're at the same observer height, I don't know if this is all taken from the same observer height, because there's a boy here and a boy here, and they don't seem to be exactly the same place. So I don't know what's going on there. But either way, this is the only photograph that he's coming up with for Looming. Now, if we're seeing this more often than any other supposed effect of refraction, and the other 5 effects, then surely they can come up with something better than this. Is this all they got? It seems that that's all he has. So it's this belief of things being come up from behind the curve, and the description of what looming is, things coming up from beyond the horizon, and then they show you this. That's all they got, right? If you go, so now I'm going to go to, right, you search Google, and they start showing you photographs like this. But you can see here I have a yellow line, right? What this is real looming, right? Where the sky is miraged onto the water, or mirrored onto the water, right? Giving the appearance of this ship floating above the horizon. But this here is, although all horizons are a visual effect, this is an optical horizon. It's like a double horizon here, because this horizon here is not an horizon so much as if there wasn't the mirroring going on, you would see further. This yellow line shows in this photograph, if you get it, it'll show that the horizon is coming along here. So this is not floating above any horizon. The ship, it's not doing that. It's actually still on the water, and the horizon is past it. But it's just the sky is mirrored onto the water. So this is what Andrew Thomas Young is describing, right, when he's describing looming, right? Let's go back, right? Looming, the appearance above the horizon of a distant object that would normally be hidden below it. So technically, he's describing this type of a situation, except for this is not hidden below it, and it wouldn't be hidden below it. The horizon is past this. The horizon is a visual effect. The definition of an horizon is the apparent juncture of the land, and water, and the sky. Right, so it's where the sky appears to meet the land and water. Right, and that all depends on the weather, depends on your observer height, depends on how good your eyesight is, and how good your optics is. There's a load of things that depend on it, but it's just a visual effect. That's all the horizon is, and it changes constantly throughout the day. It's positioned from the same observer height. It can be closer, it can be further. It's constantly changing. Here is another, right? Here is another one, but this one is not as obvious. What I mean is, there's reflections onto the water here, and from the ship onto the water, and there's a few more ripples, so it's not as calm. So it doesn't look as much. If you look at it, there's a few things stand out. It doesn't look as much like it's floating above an horizon, and there isn't a direct horizon here, but or false horizon, let's call it here. But I've put the yellow line here as to where the actual horizon there is in this photograph, and it's back here behind where the ship will be, so it'll be along here somewhere. But it's a still similar thing. Okay, it looks from a distance, it looks like it's kind of floating above something, but it's not really. It's just the sky miraging, whatever you want to say, onto the water. I'm saying mirroring for the moment. Okay, here is another one, right? Now this shows a difference in color, right here, and it looks like, but you can see the water is a bit more rough, and I put the line where the actual horizon is, which is be about here on the ship. So the ship is almost on the horizon, just before the horizon. So so this is another example of this, where it looks at a distance like it's floating above an horizon, but it's not. You can't float above an horizon. An horizon is a visual effect, not a physical thing that you can go over. Right? There is no way to ever show it to be anything more than a visual effect. Okay, an horizon you could go over would be a geometric horizon that would have to adhere to mathematics, and I've yet to have ever seen, and I know I never will see, any evidence that an horizon will conform to mathematics. Okay, now this photograph. Now this is the best one I could get. I've seen this in better definition online, other places, but I couldn't find one. So this it's not very clear, this photograph. What I mean is the resolution is the word I'm looking for. The resolution is not great, but if you, even on this one with the resolution, and it's funny that I couldn't find a better version where the resolution is better, because on the better version you can see the horizon line here a bit clearer. But this is one of these ones where this is claimed to be looming as well by people, and it's not. It's not looming at all. This is the same again. The sky is mirrored onto the water, and what you notice with all these It's the same type of conditions. Look at the conditions. It's the same type of conditions all the time, right? Same type of conditions all the time, right? So it's not a sunny day or something. It's more like a dull weather, where it's like a grey, gloomy kind of sky will cause this to happen. Okay, so this again, even though it's probably the least obvious to see, does have an horizon back here. Okay, now we're going to go on to the kind of nonsense that's pumped out by some of the globe community. Right, they're trying to say someone took this photograph, and it's May 25th, 2019, late afternoon, and they're showing this tower here in the distance. Then October the 11th, 2019, mid-morning. Right, so two different times of the day, two different times of the year of 2019, and they're showing this tower here, and we can see more of it. Now, the problem here is this, right, and I'm going to show it. This bottom one was taken from a higher elevation. I'm going to show that there now. I've put a line across the top of this tree here, and I put a line across the top of this tree, the same exact tree here. Now, what you'll notice is that here you're seeing the side of the house. This house here, you're seeing the house side on, but on this one you're looking down on the roof. You can see the shadows onto the roof. Okay, you're actually up at a higher elevation. So this is what they're trying. This is kind of nonsense they're pumping out as looming. If this is something that is the most obvious and most frequently seen effect of refraction, Rumpus has been saying it for several years. It's the one we see the most. Yet this is the best evidence they can come up with. This is all they got. Whereas, they don't have, they don't on the ball side of the argument. They don't have anything, when it comes to looming, other than those photographs I showed a few minutes ago and this kind of trickery. Now, this is trickery, obviously. They're looking down on top of the roof of the house here. You're looking at the side of the house here, on the roof of the house here. Look at the distance between here, the yellow line here, and the top of the image, and the distance between the yellow line here and the top of the image here. You're seeing more of this because you're looking up higher and down onto it. And you might even be closer to it in this one, higher and closer. And this might be further and lower. So this is what they're coming up with. Like this is nonsense. Total nonsense. But anyway, that's what unfortunately we deal with. A lot of dishonesty on the global side. But so there's this type of nonsense, and there's this type of nonsense, where things are supposed to be floating above an horizon, but that's not the actual horizon line. Is actually past that. So this is real looming, by the way. I meant to say this is actual looming, where there is an impression that something that is an impression that there's an horizon before an object that appears to be floating that isn't. The actual horizon is behind it. So as I said, it's just the sky mirroring onto the water. It's always in these conditions, always. Right? You won't see this on a sunny, lovely day. I've yet to see a photograph that shows it. You see a good few photographs that shows it under these conditions, though. So you have a grey day, and the grey, gloomy day seems to mirror the sky. Grey, gloomy sky seems to mirror onto the water. Right? That's what this is real, actual looming. Right? What we're looking at here. This is real looming. Right? Not what Andrew Thomas Young says about it. This is the description he gives due to a belief. The belief that things are coming up from behind a curve, but it is not. Now, I first said this on Randy's in a demonstration I did. I think it was late last year, or something like that. I did a presentation. Sorry, not a demonstration. A presentation on Randy's channel late last year. I first said it there. I think it was the angular size change the presentation. I talked about this, but quantum eraser and others have also talked about it since. But that's all it is. It's just the sky mirroring onto the water. Now I'm going to show Now I'm going to show something here. This is what this is what the globe thought was. Right, I'm just going to go here. Right, this is what the globe thought was. This is where the belief of something looming comes from. Right. Right. This boat is from 18 miles away, just over 18 miles away. Now, if you're looking at that from here, right, from this kind of distance, which are going to go right out. If you're looking at it from this distance, it's going to appear, because of what's happening to it refractively, it's going to appear that it's floating on the horizon, right? So I'll just play it there, turn down the sound. I'll just play it there. Go back a bit, right? Let's go back a bit. Sorry, I should. Right, it's going to appear that it's floating on the horizon. If you're looking at it with your eyes, with the naked eyes, it's going to appear to be floating along the horizon. But what we didn't have, right, for years and years and years, was super zoom cameras, like the Panasonic Lumix FZ82, the P900 and 950, and the P1000. We didn't have any of those things. We didn't have that zoom. People were lucky to get a by 15 or a by 20 zoom. And they didn't have the resolution either. They didn't have 4K video, all this kind of stuff, and 8K video. There was none of that nonsense. But so people see this and they go, that's the looming. That's the looming. It's not really there. It's loomed up above the horizon, without even asking themselves. Where is the horizon? How far away is that? They wouldn't have known. They wouldn't be able to find out. So people were like, that must be the loomed up above the horizon, and it's floating on the top of the horizon, and that's what it's doing. Right, and people believe that was looming, but what it was, right, I'm going to play it here, is inferior mirage, giving the impression. Watch, I play it. You can see it looks like it's floating along the top. Right, I'm just going to move this. It might be a little bit jumpy. It's just inferior mirage. That's all it is, giving the impression that it looks like it's floating along the top, right? But it's not. It's just inferior mirage. It's not floating along the top. It just gives the impression that it's floating along the top. And from a distance, people wouldn't have known that from their elevation height there, that the globe Earth's horizon would be, or is predicted at 10.6 miles. I was at 77 foot observer height, so the globe Earth's horizon would have been predicted at 10.6 miles. But this is over 18 miles. So for a start, there's no globe Earth horizon, right? And secondly, this isn't looming. So there's two big problems with this. So technically this is an absolute globe killer, but it's so unobvious unless you are somebody who's been in flat earth for a long time and you look at it. Most people wouldn't even notice how much of a globe killer this actually is. Things like this will be seen more as absolute globe killers in time. But this is 18 miles away. Where is the 10.6 mile horizon that should be there? It's not, if we were on a globe, it's not there, right? We're told it should be there, but it's not there. This is over 18 miles away, and it's not looming. It just has inferior mirage. So I'll just play it on again, and I'm just going to show you more up close of it. It appears to be floating. So from a distance, people went, that's looming, right? But it wasn't. It was just inferior mirage. Now, here is the boat again. Just took a still from it, and here in a more up close. Right, I changed some of the filters just to give it the edges a bit more crispness. Okay, and here is it again, more close again. Everything below the red line, right, is inferior mirage. Everything above the red line is the ship. So the actual horizon is out here, right? But there's a false horizon before the ship. Okay, right, I show you again. False horizon here before the ship. It looks like the ship is floating. It's not. It's just inferior mirage. The actual horizon is behind the ship. So people are seeing this, right, a lot more than seeing, one second, this, right? They see this effect way more than they see this effect. This is a lot. You see this a lot less. Like, it's much more seldom you'll see this. Okay, that's why there's not too many photographs of it. But loads of photographs of inferior mirage. But people were seeing it at a distance, so due to the diffraction limit, they couldn't decipher what they were seeing, right? And I'm just going to show it there. Where's the right? With the diffraction limit, they wouldn't have been able to decipher what they're seeing. So as I'm zooming out, so it's a bit blurry, right? As I go away, right, bit by bit, you can't decipher what you're seeing at the bottom, right? Right? It's starting to diffract from the bottom up, you can't decipher what's happening at the bottom. So it looks like it's floating, right? You don't know that it's inferior mirage, right? You don't know. So people just thought that must be what they call looming, where things are above the horizon that would be below, and they float on the horizon, but really they're actually go over the curve. But over the curve should have been back here somewhere, 10.6 miles, not over 18 miles. You know, and looming should have been something floating up here, right? That was visible, right? That you could see is floating with the sky behind it, right? Not this, right? Look at it. It looks like it's floating. So from an 18-mile away distance, even someone with binoculars go, that must be it's floating above the horizon. You know, that must be what that thing they call looming, right? Not understanding that from that mathematically the globe Earth's horizon is here, right? And this is over 18 miles. So you're talking about the best part of 8 miles further than what the globe Earth predicts, and it's showing what people thought was looming, which is not just inferior mirage. So as you can see, just go down here again, right? It just gives the impression that it's floating. It's not. Right, it's not. The black line is where the false horizon is, let's just say. The red line is where the actual horizon line is, because it's inferior mirage down from that. So real looming is this. That's real looming. Okay, it's very, very, very rare. You won't see it very often, and it happens in these conditions as the sky mirroring onto the water. That's all it is. Right? You can say miraging if you want. I don't know what the correct term is, but mirroring is good enough for me. That's all that's happening, giving the impression of something floating. This is not looming. This is 8 miles past the geometric horizon prediction, and it's inferior mirage at the bottom. So it gave the impression of looming. And things are not looming up from behind the curve because there is no curve. That's the end of that. A bit longer than I expected it to be, but it is what it is. Hope you got something out of it, and that what I've shown here can be brought forward into the argument. Thank you.